Hello and welcome to How a Semantic Layer Makes Data Mesh Work at Scale. Today's webinar is sponsored by AtScale and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech Media and I'm excited to be your moderator for this special event. Now, before we get to today's great content, we do have a few housekeeping items that will help you get the most out of this session. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in our webinar control panel. Not only will we have team members responding to questions during the live event, we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that you ask. That Q&A panel is also the place to let us know about any technical issues that you might be experiencing. A browser refresh is going to fix most audio, video, and slide advancement issues, but if that doesn't work, just let us know in the Q&A and we'll provide further technical assistance. Second, in your handout section of your webinar control panel, you'll find that we're offering several resources, and I'd especially like to call your attention to 4 PDFs from AtScale. Those include customer case studies with Tyson Foods, Wayfair, and Cardinal Health, along with a complete buyer's guide for a semantic layer. Also in there, you'll find links to some ATM resources like the Gorilla Guide Book Club and the Event Center, which has our calendar of upcoming events. So I encourage you to access those resources now and share them with your friends and colleagues. Third, at the end of this webinar event, we will be awarding a $300 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for that prize. The official terms and conditions of today's prize drawing can be found also in your handout section. Just scroll to the bottom and you'll find the prize terms and conditions link there. And finally, one of the best benefits of this event is the opportunity to ask a question of our expert presenter. So to help encourage your questions, we have a special additional prize for you. That's a $50 Amazon gift card for the best question. At the end of the event, we'll look at all the questions, pick out the best one, and contact that prize winner. With that, let's get to today's fantastic content. It's my pleasure to introduce you to our presenter today. It's Dave Mariani, founder and CTO of AtScale. Dave,
Hi,
welcome.
Scott. Thanks for having me. Thank you for having me.
Thanks for being here. Yeah, I'm really looking forward to hearing about AtScale and the semantic layer. So take it away.
Sounds good. Thanks, Scott. So thanks for everybody for joining today. Today we're going to, like Scott mentioned, we're going to talk about a semantic layer and specifically how can it really enable a data mesh style of analytics organization. So it's going to be some good stuff there. So looking forward to your questions, please keep them coming when you have them. So it's not just going to be a presentation. I'm actually going to show you how a semantic layer works in action. That's going to be a live demo. So no net, no safety net. So I'll be building a semantic layer before your eyes, and then showing you how that semantic layer, first of all, how it supports a data mesh style architecture of analytics organization, and also how to then consume that semantic layer in various tools. So with that, let's just first start with a definition. So what is a semantic layer? Well, a semantic layer, if you just do a Google search, you'll come up with this at the top of the search. It comes straight from Wikipedia. Their emphasis, not mine, on the bolding, but I think they did a good job. A semantic layer, essentially, the keywords to pull out of this paragraph is really, it's a business representation of data. And that's important, right? It's not a technical representation. It's not tables and columns. It's not for data engineers. A semantic layer is for business people, for people who need to ask questions to actually solve a business problem. And the second half of that bolded statement there really says why do we want to have a logical layer on top of our physical data assets? Well, it's to truly promote self-service. And we've been talking about analytics self-service for the past decade or so, and popularized by tools like Tableau and now Power BI. But at the end of the day, you need to be pretty darn technical to use those tools, because it's not about just creating visualizations or answering business questions. It's really forcing you to understand how your data is laid out, where to go get it, and how to log on and fetch it, and then how to model it. And so we're asking users, analytics users, to do a whole lot there. So what the semantic layer is, because it's that logical layer, we're going to separate the creation of the model from the consumption of the model, and we'll talk about that in just a minute here. So why do we even want a semantic layer? Why not just access data straight and just give data straight access to your business users? Well, besides the fact that it's hard for them and they have to have a skill set. It also creates all kinds of different problems when it's a free for all. Obviously, consistency is a problem. So you can see in the picture on the left over here, where basically the semantic layer has been embedded mostly in BI tools since the beginning. Business objects created the universe, and then you have every other BI tool creating their own semantic layer to sort of keep you in their walled garden. And that's not good enough. It's not good enough because if you have more than one tool, well, then you have more than one semantic layer. And with today's modern tools, it's a semantic layer per workbook. So even the same user can come up with a different definition of revenue or return on investment, even within the context of their own workbooks. So a lack of consistency drives a mistrust in data. And when people don't trust data and the results, all kinds of bad things happen after that. You really are stymied into making good decisions and moving fast. The other part of it is control. So, my philosophy has always been, is like put it all out there and then secure it, as opposed to try to build into your pipeline roadblocks where it's tough for people to get access to data. You want to have people to get access to whatever data that they are supposed to have access to, but you need a governance layer, and the semantic layer can really serve that role. Because it's a broker and the queries go through the semantic layer, you can apply row level security, object level security, masking, the like, so that users, depending on their groups and their privileges, can only see the data they're supposed to see. But there's never a physical restriction. Again, it's a logical restriction and applied at the business level, so you can make business rules rather than technical rules, and trying to secure columns in a table, for example, versus a term like a customer and PII. And then finally, it's really about agility. So if you have really lengthy and big data pipelines, those data pipelines are the only way to deliver access to data, physical data pipelines. So then it takes a long time to go from a new data set to something that's consumable by the business. And a semantic layer could really shortcut that because it relies on virtualization and a logical view of that data. You can get very far, very fast without having to go through the typical data pipeline hops and jumps. So where does that semantic layer fit when it comes to the stack and our modern analytics stack? Well, I'm just going to talk about cloud today because that's where most people are going to. And a semantic layer fits right there what you see. It's in between the consumption layer or the consumers of that data and the data sources themselves. And then what you have over there on the right is you have the enterprise data catalog, which is really sort of communicating with metadata with all those layers. And it's important that the semantic layer also communicates with that enterprise data catalog. So let's talk about the consumption layer first. Well, you have three different sort of categories. First is your business analysts who are using BI tools. And those are going to tend to be like tools like Tableau and Power BI. And a tool that most people don't think of, which is Excel, which is the most popular BI tool out there on the planet still today. You may not consider Excel as a BI tool, but it is definitely a place where data lives. And I'm going to show you how you can connect Excel to a semantic layer without having to do data copies or data dumps and create spread marks in place of that really defeats the purpose of that semantic layer. The next sort of category is data scientists. And data scientists are going to consume, obviously, with Python and Jupyter notebooks and AutoML platforms. And then you have your application developers who are going to write code to embed analytics in your applications. And they're going to be using tools like programming languages that are going to be using access protocols like ODBC and JDBC and RESTful interfaces. So the BI users can use anything from SQL. If they're using Power BI, they're going to be wanting to use DAX. If they're using Excel, they can only use MBX if a live connection. You got your data scientists who are using Python. You got your application developers who are using REST, ODBC, and JDBC. So the really important consideration for a semantic layer is it can speak all those languages. Just just presenting a SQL interface to your consumers is not good enough because it's not rich enough for the modern BI tools. It's not fast enough, and it's not going to be able to do the job for all those different user groups. And if a semantic layer isn't universal, it's not much good, is it? Unless everybody is using that same semantic layer, regardless of the tool that they're consuming in, then you really can't drive consistency because there's still going to be these silos of semantics living outside of that semantic layer. The other thing that's important about a semantic layer is it can plug into any type of data, whether that be a cloud data warehouse, whether that be an on-prem data warehouse for that matter, whether it be a data lake through interfaces like Databricks SQL and supporting a lakehouse type of style of architecture, or even SaaS applications like Salesforce. All that data is locked away in proprietary formats, in different formats, and the semantic layer does a great job at hiding that complexity. So it creates that abstraction layer. So besides hiding the complexity about where the data is living or how it's living from those consumers, it also gives IT the flexibility of moving those data platforms around, moving data to different platforms, or even introducing or migrating to new platforms without disrupting any of the consumption that's happening at the top. So that's really that's a lot of flexibility. I like to think of a semantic layer as really future-proofing your architecture, whether it comes to consumption or whether it comes to the actual data itself. You're not tied to any single platform, and that's a pretty powerful advantage. So, what is a semantic layer really? What is it powered by? It's powered actually by a semantic model. And a semantic model is what translates the logical from the physical. And you see a picture here of a model. This is what I'm going to show you. I'm going to build this today. And this is what's called Design Center. This is how we in AtScale build a semantic layer. And really, we've really created two separate roles when it comes to analytics production. We said that there's a data steward role, and the data steward is going to be using this view. They're going to be in the business probably. They're going to understand, they're going to be in finance, they might be in marketing, they might be in sales. They're going to understand their data and their domain. And they're going to encapsulate all that logic, the business logic, and those physical transformations into a logical view so that the consumers can consume using the tools that they want to use. So here's an example of a view of that a consumer might see. They're going to see one model and they're to see it represented in a number of different ways, including Python and Jupyter notebooks, or just plain old ODBC, JDBC, and REST for your developers. So one model, one semantic view on top of your physical data that's authored by a data steward once and then consumed many by anybody who has a BI tool or Excel. So what is a semantic layer like? What are some of the common use cases that we see out there for a semantic layer? The first one, which is obviously very popular, is a sort of cloud analytics optimization use case, and that's a case where look, people are very anxious to take advantage of the cloud and get out of the business of having to manage their own analytics infrastructure. Well, that's terrific, but there's a lot of gotchas along the way. One of them is that people assume that when you move to the cloud and you move to platforms like a Snowflake or a Databricks or a Google BigQuery, that all your performance problems are going to go out the window. It's just another database, and there's only so much you can do when it comes to performance. So a lot of people are disappointed by that speed, thinking they can get rid of Tableau data extracts, for example, or get rid of Power BI imports, and they still end up living with those. And so performance from an analytics perspective is a problem. Performance could be wonderful for other use cases, but for BI use cases especially, you really do need sub-second performance. That doesn't always come with come with those platforms. Also, when it comes to cost management, the more people, the more easy it's easier to access. The more people are going to access data, and if they're writing handwritten queries, they could cost you a lot of money. So it makes much more sense for machine generated queries than human generated queries, because you obviously can control those machine generated queries, and you can make sure that they're consistent and they're not going to repeat mistakes or even repeat patterns that don't need repeating. And I'll show you more than that in a second. You might hear about a lot about enterprise metric stores. You might hear about headless BI. There's all different names, semantic layers. They're all synonyms for the fact is that we want a repository for our business metrics. We want to know there's a common definition of revenue. There's a common definition of cost. There's a common definition of time, of location, of product. And those aren't trivial. Those aren't trivial problems to solve. And so an enterprise metric store or through a semantic layer can really provide that consistency so everyone's speaking the same language. The other problem is that today we think of the data scientist and the business analyst as two separate domains, and it is. They're two separate silos. You have your business analysts who are working on basically what happened yesterday. So they're using descriptive analysis through reports and dashboards, maybe a little bit of diagnostic baked in there. And then your data scientists are thinking about the future. So they're doing predictive and prescriptive analysis. The semantic layer can be the place that joins together all four of those analytic styles. So that your data science could be using a semantic layer to drive consistent models and create new derived features and derived predictions from that semantic layer, and then write it back to the semantic layer so that then the rest of your application developers, other data scientists, as well as your BI users can take advantage of it. So imagine if you have something like sales, for example. Well, sales is historical sales. Well, I can then look at forecasted sales right next to it. That's going to typically come from a machine learning algorithm, even if it's a simple regression model. And so the benefits of a semantic layer can put those two predictive and descriptive types of metrics in the same place, so you can compare and use them, as well as taking advantage of broader distribution beyond just a single user or a single file. And then I'm sure everybody has OLAP tools. OLAP was born for a reason. It is a business-friendly language. We believe that a semantic layer needs to be basically multi-dimensional, because that's the interface that business wants to use. They understand dimensions, they understand metrics, they understand hierarchies and roll-ups. It's a very human way of thinking about data. And so the problem with OLAP is data ran past it, didn't scale anymore. It was slow. It caused lots of data copies and latency and all kinds of complexity. Well, so users and customers who are looking to modernize on that capability still want multidimensional analysis, but want to work in the cloud and at scale. That's where a semantic layer can really help. Okay, so we've seen some of these use cases. And I want to now talk a little bit about just how companies deliver analytics to the business today. And I'm going to put a challenge in front of you to say that that you've heard about data mesh, you've heard about maybe hub and spoke, and I want to put some ideas out there on some of the ways you can achieve this. Because I hear a lot of customers who are really sort of struggling with. They love the concept in theory, but it does seem like a theory. And it doesn't need to be a theory at all, as long as you have a semantic layer to help power that movement. And it is a movement. So today, we typically see this style, or a lot, and traditionally, we've seen a centralized sort of style of analytics delivery. And typically, you have a data team. Maybe it's a center of excellence. Maybe it's the office of the CDO, whatever you want to call it. And they typically are doling data out to the business. In the old days, they did much more than just giving them data. They also actually drafted the reports for them and the dashboards for them. That's sort of given way to more sort of self-service and when it comes to visualization. But we still haven't really gotten away from how data is actually delivered to the business. It still tends to be pretty monolithic and pretty centralized. Well, there's a different alternative, and some people want to do this. This is like, well, just let the business units create their own data assets, manage their own pipelines, and do their own analytics, and then let them share it with each other. That's great in concept. It's a purely decentralized approach, but it does a couple things. It typically the data mesh definition by as it's written doesn't really talk about a COE or a data team that helps to establish some standards. I think that's really important. Hub and Spoke tends to have that in place, where you have a team who is responsible for the types of the data pipelines and the data pipelines that are feeding the business. They could be in charge of tool selection in terms of SLAs for delivery of data. So allow the business to add their knowledge to create those data assets, because you can't ask a finance data steward, a finance person, to create marketing models, and you can't do that vice versa either. So it's really also hard to ask a data engineer to have to understand the business. That's a tough ask, especially when they have to understand all aspects of the business. So I have a proposal to sort of to deliver the best of both worlds here. And really, it's really a data mesh style, but with a semantic layer acting as the glue to glue together these different groups. And if you notice, I still have that data team there in place in the lower right-hand corner. I haven't gotten rid of them because the data team is really important for, again, establishing those standards, but also for managing that semantic layer platform. And so, for example, that central data team may be responsible for some core data assets like a time dimension, because we all want to be talking at the same time. That's where things immediately go off the rails. I know that sounds really easy, but if you're a retailer, you know that there's different ways of looking at the retail year with a 445, which is seasonal based, calendar based, fiscal calendar based. There's all kinds of ways of looking at data, and it's really important that everybody speak the same language there. So, for example, you could have the data team owning that time dimension in the semantic layer repository. I'm calling it a repository because that's what it is. It's a library where you have read-write access and you have stewardship or ownership over those assets, but you can share them with these other teams. You might have the marketing team who is creating their campaign dimension. So maybe they own that dimension because obviously they're creating campaigns. They understand them. They understand how you want to roll them up and how you want to use them in a hierarchy. And you know what? They may create a campaign model that they want to share with with obviously with their own team members, but maybe with other teams. You may have, for example, the sales team who's creating a sales ops model. And they may be using that time dimension just like the marketing team is using the common time dimension. And then you may have like the finance team who are creating their own models, like a cost model, again, which make use of that time, that core time dimension. But then what happens if you want to put those models together? So why would you want to put the models together? So what if you want to know what's my ROI by campaign type? Am I making more money in display advertising, in print advertising, or what have you? Well, now with this approach, you can put those models together and create blended models. In this case, I call it the campaign ROI model, where you can combine the campaign and the cost model together just by clicking them together on those conformed dimensions like Lego blocks. So now what do we have here? Right? What we have here is we still have the business who are owning the context of the data. They understand their business, but they're able to encapsulate that knowledge within a model, but then share that model with others without those other teams or those other domains needing to understand the other team's domain. So it's a way of encapsulating your domain knowledge, but then sharing it in a common way in a Rosetta Stone style with other teams to create all new mashups that for driving all new insights. So you can see that this is a way that you can actually promote that decentralized style without losing control and without creating chaos by having still people speaking the same language and being able to share data assets with each other. So I'm going to show you that in a demo in just 1 minute here. So let's just sum it up and then we'll get into the demo. Uh, First of all, like, why invest in a semantic layer? Everybody wants to speak the same language. I mean, it's like there's such a a lack of trust in data these days, and it's because if you were like me, I learned all this the hard way. I ran analytics and data for Yahoo and had the most simplest metrics in the world, clicks and page views, and nobody could agree on what those definitions were, and so we had chaos even at the most basic level. So if everybody's speaking the same language, everybody rolls up data the same way, uses time the same way, calls things the way that one way that when there's one source of truth for those metrics, then you can drive trust and you can drive a lot more consumption with that trust. If everybody can ask questions, well, now you have analytics for everyone. Today it's like we've really taken a step back from the old app days, haven't we? We've taken data out of the hands of the business, and we said that you now have to have a skill set that allows you to understand cloud data warehouses or data lakes, for God's sakes, and then be able to put those together, model data in a new tool, and then from there you can finally get your work done. A semantic layer really separates those different roles out and doesn't require one person to be able to do it all. That means everybody can make a decision. We are able now to manage that data mesh style of architecture without creating chaos. I would not recommend trying to implement a data mesh style without a semantic layer. I think that's a recipe for disaster for the reasons I pointed out. Data governance is key. You don't need to have a separate data governance tool. Data governance is all part of the semantic layer. It's the same thing as like if calling revenue is just as important from a governance perspective than it is whether I can see PII or not. So to me, that's a core feature and a core requirement in a good semantic layer. And then as we talked, it really future-proofs your investments. Because we're not directly tying consumption to the physical data assets, you wouldn't do that as a programmer. You would never actually promote people talking to databases without a Hibernate or without an ORM layer. You wouldn't do that. You shouldn't do that with your data assets either. Because then you're going to be stuck, and you're going to be stuck when you want to introduce a new data asset or whether you might want to move from one cloud to another, for example. Okay, so that's all for slides for now. So let me get into a screen share here, and let's get busy. Today, what I'm going to do, I'll share my screen. And hopefully you can see that fine.
I see it, Dave.
Awesome. Thank you, Scott. Okay, so what you're seeing here is what you saw in that slide that I showed you. This is called Design Center. This is an example of a model. Quick orientation. On the left is your data assets. And your data assets, the blues are just physical tables. The greens are actually other embedded models. So I have models within models here. What you see on the right here is you see what the consumers are going to see. So they see nice business-friendly metrics. They see data that's organized along dimensions. Those dimensions can have hierarchies for doing roll-ups. It's really user-friendly for sure. Okay, so how did I create this? So here's what I'm going to do. I'm going to play two roles in today's demonstration. I'm going to first play the role of a data steward. And this is, for me, I'm a merchandiser. And for today's example, it's going to be a retail example. I'm going to be working off of BigQuery as my warehouse. And so I'm connected straight to BigQuery right now through Design Center. And I'm going to create Scott is our host today. So I'm going to create Scott's web store. That's our model that we're going to be creating today. So I'll go ahead and create a new model here. I'm going to go ahead and then enter into our canvas. And in our canvas, I'm now going to I'm going to go ahead and create that new model and create that new data. Okay. So the first things first, you can see my canvas is blank. I'm going to go to my data sources panel, and you can see I have a bunch of different data sources that are sort of loaded up here. This is all just by connecting the semantic layer to your data assets. This happens to be BigQuery data. You can see I have a bunch of different tables. I can do previews on that table, on those tables. I know as a retailer, I'm going to first start with my sales log, because my sales log is, if I double click it and I get into a preview of it, my sales log is all my raw data for my sales. And you can see I have orders, and so I have SKUs in here. But I have a real mismatch. This is a transactional table. So I have some dates, like if there's an order date that is a number. I have another version of that order date, which is a string. I have ship dates. I got some data that are nulls. That happens to be some nested data in there. I might want to clean that data up. So a semantic layer is a core feature of a semantic layer is virtualization. And that what I can do here is I can create transformations without making them physical transformations. So I just cleaned up my sales reasons column by replacing nulls with unknowns. And I can do that. I can also create brand new data elements. Like I'll create a sales tax, for example, and I'll write a formula. Now I'm writing a formula here by taking the sales amount, that's the amount of the sale, and multiplying it times 8.5%. I think it's even higher here in California now, unfortunately. Well, by doing so, I just created a snippet of BigQuery SQL. And now I'm going to have a new calculation for sales tax, and you see it right over here, my calculation for sales tax. If I come back to my main canvas here and I scroll down, I now have sales tax as a new calculated column that's part of my model. So this is now a shareable object. So if I want to share this with another data steward, they're not going to have to come up with their own definition of sales tax. Now, I know that was a really simple, super simple, silly calculation. You can imagine that these calculations could get as complicated as you can imagine. Anything that the BigQuery, in this case, could do, so could the semantic layer. If it's talking to Snowflake, if it's talking to Databricks, if it's talking to Redshift, all the same holds true. So I'm going to turn that into a measure, and I'm going to put it into a folder, and I'm going to show that I have my very first measure in Scott's web store model called sales tax. It's in a folder called sales metrics because I'm organizing my data for my users, my consumers here. I definitely know that I'm going to want to be able to count up the number of items that are ordered by order quantity, by SKU. So I'm going to create that as a measure. I'm going to do the same thing with sales amount. I want to know how much people are buying in terms of their basket. And just like that, I now have 3 metrics in my model: order quantity, sales amount, and sales tax. Okay, so here's where the data mesh style really starts to pick up. I'm going to come into my library view here. And I see in my library, I have a bunch of different assets I can use. I even have a row level security dimension here that I can be pulling on to apply row level security. So let's just do this. I'm going to pull in customer. I'm going to pull in product. And I'm going to pull in, of course, time, my date dimension. Okay, so first of all, I'm a retailer. So you can notice I have a retail 445 and I have a PP 445 kind of hierarchy in there. So there's lots of ways of rolling up data. Doesn't mean you have to restrict users. Sometimes you want to see fiscal. Sometimes you want to see calendar. Sometimes you want to see reporting, in which case is 445. And I want to see all of them. And I can see all of them, but I can be assured that no matter how I cut the data, the results are always going to be correct. So then how do I then link these up? I have this sales log file or table. And the way I link them up is I take my customer key, join it up to my customer model. That creates what we call a relationship. And then voila, what I see over here on the right is I've got all these data elements. I got all these data elements because I connected up to the customer dimension model. Now, I could have been the data steward who owned the customer dimension model. It could have been that central data team. It could have been the marketing team. or it could have been the sales team who owns that. It doesn't matter. But I'm able to use it with and get all this free logic, including different hierarchies for how I roll up users just by connecting it. So the way that happened, if I double click it, is that you notice that the customer dimension model has a table for customers, but then it has itself two other embedded models, including a geography model. And that geography model, that's where I have my security dimension that's applied to my region. So I can filter user access based on where they live. They can only see the data for their geographical region. And that means that all that logic came along with that one single connection there. And really, that's the power, right? Because we're talking about like Lego bricks now. We're talking about putting together these models without having to reinvent the wheel every time. So we've driven consistency there at the customer level. We'll do the same thing and drive consistency at the product level. I definitely want everybody to be rolling up my products the same way. And in fact, that's what they did. There's my product hierarchy. How about time? I got order dates, I got ship dates. Well, let's connect up and let's do order date first. I'm going to connect it up to my hierarchy over here. And now if I click OK, what I see is I see that I have order dates. Here's all my different attributes, about everything I want to know about time, as well as two different ways of rolling it up by day, week, year, and day, month, quarter, year, just by clicking and creating that relationship. Well, I also know that I don't just have orders. I also have, order dates. I also have ship dates. So I'm just going to give that a prefix. We call this role playing. And it's a really important concept because it allows you to create similar data types and have them mean different things without having to reinvent the wheel or create complicated dimension tables. Now, I'm going to click on my product info field. Trust me that I have it recognized that there's this is nested data. I'm going to pull out the keys in that nested data of color and style. And those become now virtual columns in my data set that I can immediately dimensionalize just by pulling them into my dimension panel that you see over there to the right. So I'm not calling up IT and having them build me these dimension tables. I went ahead and did it without ETL and without unnesting the data. The semantic layer is going to do that for me. So now that I have my model, I'm ready to go. I'm ready to publish this. And when I say publish this, I mean I'm going to make it available to my my business users or my data scientists, for that matter, or my application developers to consume. So here's where we're going to start. I'm going to go ahead and publish. I finished publishing that model now. That was just an XML definition. There's my Scott's web store. And I'm going to start to have some fun with Scott's web store here. So let's first go and let's start with looking at that analysis in Tableau first. So let's go and log into Tableau. So what I'm doing here is I'm going to use Tableau, and I'm going to use Tableau in SQL mode. But what you're going to see here is that through the AtScale semantic layer, we actually shared that semantics with Tableau through a Tableau data source. So we're not exporting data here in Tableau. We're connecting Tableau live to the semantic layer. So we're not creating another copy. We're not using data extracts. I'm going to connect with Joe as Joe. So you can see how our row level security is working here, because I'm going to connect as myself using LDAP in a second in my Windows environment. So as connected to my Tableau data here, I'm going to see here that I'm going to have my semantic layer all ready to go, and I'm going to start to drive some live queries here in my Tableau environment. Okay, come on, Tableau, let's go. Okay, well, we're going to let Tableau connect there. And while Tableau is connecting, we're going to go ahead and connect live to Excel. And I'm going to connect to Excel through the built-in analysis services driver. So this is important. We're using now with Excel. We're actually logging in with our single sign-on with our Windows authentication, and we're going to connect to our semantic model using Excel in this case. So here you see there's my project that I just created, and there's Scott's web store. So I'm going to go ahead and click Finish. I'm going to leave it as a pivot report. And I'm going to go ahead and log in to my semantic layer, and I'm going to see my semantic layer now here over on the right as a live pivot table. Now, what does that mean as a live pivot table? You can see there it is. That's the semantic layer. You can see my three metrics. Those are what I just created. And now what I'm doing is I'm not doing data copies at this point. Now what I'm doing is I'm doing live queries against my semantic layer. These are live queries against BigQuery. And there you have it. There's my product order quantity by color. Now, I don't need to have those to be formulas, be a pivot table. I can use just the native Excel functionality to turn these into individual coordinates. Now, what does that mean? That means that I can actually embed these different coordinates in my workbook and have them live independently from my own calculations or my own data. And that's really important. You see how it says cube value here, how these now are coordinates? That means that these now cells can live separate and distinct from the core data. And that's really important because now I can go ahead and put those anywhere on my sheet, and those are going to be able to live separately and distinctly. And when it comes time to refresh them, I can just go ahead and refresh them, and that's going to go ahead and refresh that data live in place wherever that data may be. And these again are making all live queries to my BigQuery warehouse all through that semantic layer. So that's really power, and that's not abusing Excel, because now Excel is a live connected sheet to your data, rather than it being a data dumping ground, rather than it being a spread mart like you expect Excel to be. So let's go to Power BI, and let's look at Power BI, and let's go ahead and get data the same kind of way. We're going to go through analysis services here, and I'm going to go ahead and get that same connection here that I got before. Now Excel was speaking MDX. That's the only way Excel can speak. In this case, I'm speaking and I'm connecting live using Power BI and DAX. Now, why is that important? Why is it important to use to be able to connect live with Power BI? Well, because most of the time, what I'm going to be doing is I'm going to have to connect and connect to directly to BigQuery. And the only way that you can really make that work, you see there's Scott's web store, is to actually import the data into Power BI. And we don't want to do that because as soon as we create Tableau extracts, as soon as we import data into tools like Power BI, we now create data copies. We created risk from a governance perspective, and we've also created latency because now that data needs to be refreshed. And now we've created an extra process to refresh that data. So there's my Scott's web store. There's my metrics again. And what you see is what you get. I'm just pointing and clicking. I don't need to go ahead and do anything more than I don't have to model data. I don't have to understand where it came from because that data model, as you see right here, is all transparent to the user. This all comes free. This is the model that the data steward using Design Center created. So now I don't need to worry about having to model the data. I can just go and point and click and take care of and use all of that logic that's already been done for me, including all my hierarchies and the like. So finally, let's sort of bring it home here. I want to take you to our query log here because I want to show you the life of Scott's web store. So these are all the queries that we were just running there for you, and you can see that very first query we didn't use. You can see there's NA for optimization. By the second query, AtScale already understood from this Excel query and actually created and used an aggregate table in place of the raw table. So it got busy and it started to use aggregates. And you look at this last query here, this query took 174 milliseconds. And you can see that it used an aggregate, and it used also a cache to be able to deliver that query in 174 milliseconds. So this is how a semantic layer can work. It's not only that it's going to provide a business-friendly view of that data for your business, it's also going to make it fast, and it's also going to govern it regardless of who the person is, because they're going to log in as themselves, and they're going to all play by the same rules. So with that, that sort of concludes my demonstration. And Scott, I'll hand it back for you to see if there's any questions in the audience.
All right, super. Yeah, and as we're waiting for those audience questions to roll in, I just have to say I'm very excited about my web store, and looking forward to playing with those sales metrics. I'm especially interested to model how that California sales tax is going to affect my my overall demand. So thanks for setting that up. I appreciate it. Hey, one of the questions that I had is, about how it maps those technical field labels from from your data to those business terms. Is that automated at all, or is it all wizard driven where you pick, or like is there an automated where it gives a first pass and then you go through, your data steward goes through and confirms? How does that work?
Yeah, we definitely have automation there. So as you drag that in, we're going to beautify those column names and turn them into something that's business friendly. And of course, you can always override them and change them. And I showed that picture of the data catalog running along on the right side. This is where exchange with a semantic model from a data catalog really makes sense, right? Because then you can make sure everybody's creating models with the right terminology. But what AtScale will do is it will beautify that for you and allow you to override them. In the future, we'll be taking those definitions as a hint from the data catalog as well.
Okay. All right. Super. Hey, and you showed that data mesh model, with the sales team and finance and marketing and the data team. That was really interesting. What is the best practice that you recommend in terms of who's the project owner? Like, what department does that come from? Does it have to be somebody in the C-suite, to make sure, like, when there's conflict over what the definition should be, say this is how we need to run the business, or is it somebody lower level can generally run that? What really works for your customers?
I've seen our most successful customers use a hub and spoke style. So the hub is usually a central data team that has sort of like acts as like sometimes a broker, sometimes a referee, but most of the time as sort of helpers, a center of excellence. And so, it's when it comes to sort of common dimensions of the business, I think it's best if they come out of there. And I think that when it comes to specific dimensions, those should live with the businesses themselves because they understand those. But I think it's really important to take and identify what the common business dimensions are, and to make sure that those are all owned by a central team, the hub. That's what I would do.
Okay, gotcha. No, that sounds great. And also, Martin says nice about the demo. He really liked the demo, so appreciate that. I agree. That was a great demo, and without a net, really nicely done. Another question we have in here is, how does the semantic layer help with data governance? I think that wasn't something that was in the demo necessarily, but how do you sort of add in there like PII protections and things like that? How does that work?
Yeah, I mean, a couple ways, Scott. So one way is I went really fast in the demo, but there was that security dimension. That was an example of applying row level security. So what we would do is for every query, any query that touches relationship wise. So what AtScale does is that from that dimensional model, it creates a knowledge graph that drives our query planner. That's how we generate SQL to the back end, BigQuery in this example. And so what we'll do is we'll apply those row level security filters as where clauses on the fly anytime any relationship in the model touches that geography or location dimension. That's one type. That's filtering rows. The other part is
Okay.
like is what we call perspectives, and in perspectives you can hide or show columns or mask them, and you can do that through perspectives or column level security. And then you just have identity management. So that all is integration with your directory groups and directory users, and then you use those to apply permissions, RBAC policies, right, to be able to control who can do what from a feature function wise.
Okay. All right. Super. Hey, on one of the early slides, you were showing sort of the scope of the problem and all the different tools and how they sort of mix together data layers and semantic layers, and that was sort of the advantage of AtScale, was you guys were providing a consistent semantic layer. I imagine uh, it's not necessarily clean with a lot of those tools, like the difference between the data layer and semantic layer. When you guys are accessing it, do you go like directly through via APIs to get directly to the data, or do you have to translate some of their semantic stuff as well into your tools? I hope I'm not getting into your secret sauce, but how do you handle that between different tools and how they work?
No, that's a great question. And look, when we connect to the data, we're going to connect with native APIs, and that's typically going to be JDBC. So we're going to be able to see the catalogs just through JDBC. So we don't require users to actually have to first map your physical data into AtScale's parlance before you can actually model it. That would be crazy.
Yeah,
So when you saw me pull up that data folder, that data sources panel, that all automatically populated by itself just by creating the connection to those individual data sources using JDBC.
fantastic. Okay, great. Uh, let's see. Oh, here's one. So, how do the aggregates stay in sync with the source data?
Yeah, so you saw me create those. When I say aggregates, those were aggregate tables, and those aggregate tables were just big BigQuery tables. Think of them as materialized views. So a lot of people, if they're trying to do this on their own, they'll do data engineering. Well, they'll create aggregate tables or materialized views manually. What AtScale was doing behind the scenes is based on my query patterns that I was clicking around on. It was actually decided, what a good aggregate table would be, and it built it, and then it used it in the subsequent queries. So the
Hmm.
question is, okay, well, how does that data stay in sync? You could do it three different ways. You can make it time based, so on a calendar, on a schedule, we can update it every n minutes. You could do it on a triggered basis. So after my pipeline gets refreshed, please update my aggregates, and then AtScale will figure out all the dependencies and what to update, and whether to do it as a full update, meaning a from scratch update, or incremental update, which is to change data. So lots and lots of sophistication when it comes to that.
Okay. All right, great. Hey, there's another question here. Why can't we just connect our BI tools to the data platforms? I mean, I think you explained a lot of that, but um, what are some of the reasons that makes a lot of sense to have you guys in between?
Yeah, if you think about a common pattern today, especially with the cloud data platforms, you always have some kind of a BI layer on top of your Snowflake or your Synapse or your Redshift or your BigQuery in my case, or even Snowflake. And typically you see it a lot with Power BI and Power BI Premium. Power BI Premium is SQL Server analysis services under the surface. And so what you have to do is import data into Power BI. Or if you're using Tableau, you create Tableau data extracts. That's just using their hyper engine. It means you're moving data out of that platform that you've taken all the time to build out and scale out, and then you're
Mhm.
like shrinking it back down to something that runs on a PC. It's insane. And so yeah, you can connect. You can't. That's what you need to do to actually make it perform it. So yes, you can connect live. Does anybody connect live and do real work that way? Absolutely not. And so what they do is they create these other beasts out there where they have these little PC file caches
Mhm.
that need to be updated, and hold a fraction of your very old data.
Yeah.
So yes, you can. Do you want to? No.
Great. I like that answer. That's great. Another one here, they're asking who's responsible for creating the semantic models?
Yeah, it depends on your style. We have customers who do the centralized style, so the COE, where they're creating the models, and then the business is consuming those models. I think that I've seen the more advanced way of doing that would be as hub and spoke style. So you have maybe the hub is responsible for the common dimensions, and then the business is responsible for modeling using the AtScale design center that's creating those semantic models on their own, and then sharing those with each other. I think that's the best sort of trade-off, and because it gives you the best of both worlds. The business gets to own their own destiny, apply their knowledge of the business and their knowledge of data in one place, and then you still have control because you're speaking the same language. So I would say distribute that semantic model building to the business, and as long as you have a central team that's managing the platform, the access to that platform, and the common assets that power that platform.
Okay. All right, great. Well, hey, as somebody who got into tech journalism in 1998, my first story was about OLAP, and so trying to figure out what that was. I could ask you questions about this all day. Fascinating stuff, but unfortunately, we've got to wrap it up. Any closing thoughts as far as where people can get started with AtScale and learn more?
Yeah, we have a lot of great. There's some great handouts that are in the handout section there. Those are case studies on some of our biggest and largest customers, so you can hear about how they put a semantic layer to work. We have lots of great assets on atscale.com. Go to the resources page to learn more. It's really about customers speaking and partners speaking about how these things all fit together. There's a lot of good content in there that can really help somebody understand this whole space and how it relates in the new modern data and analytics landscape.
Okay, excellent. Yeah, and those four PDFs are in there. Grab them now. The session's about to end, so this is your last chance to grab them here. Dave, thank you so much for coming on. This was a really fascinating discussion, and appreciate the demo too. It was a great demo. Thank you for the update on AtScale.
Thank you, everyone.
All right, and with that, oops. With that, we have one more piece of business here. It's the $300 Amazon gift card prize drawing, and the winner of that gift card today is Jim Shih, SHIH, from California. So congratulations to Jim. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I do want to thank AtScale and Dave for making this event possible. And thanks as always for attending. That concludes today's event. Have a fantastic rest of your day.